Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about how to analyze disability data. I will be mostly focusing on 4 different types of analysis. The first is hierarchical cluster analysis. Second would be custom tables. The third would be decision tree. And the last one is two-step cluster analysis. To carry out this analysis, I'm using a data which is called as disability data. I will be carrying out the analysis for 30 different districts of Karnataka. As you can see here, this is the district level information that I have. I have different districts like Bagalkot, Bangalore, Bangalore Rural, Belgaum, Bellary, Bidar, Bijapur, so on and so forth. Against each of these districts, I've got important information like total population, disability in seeing, then I have the variable disability in hearing. There are 8 different types of disability that I'm studying in this data. As I've already mentioned, we have seen disability in seeing, disability in hearing. Let's now look at the next type of disability, which is disability in speech. Then we have another variable which is called as disability in movement. Further, you have mental retardation, mental illness, other disability, multiple disability, and the last variable here is no disability. The total population has been broken down into 8 different types of disability, which we are going to analyze. What is the sample size in this particular data? When I look at the overall sample size, you can see here the sample size here would be 30. It would be difficult to carry out traditional statistical analysis. The one analysis which we can carry out is called as hierarchical cluster analysis. Hierarchical cluster analysis typically is used for small samples. How small is a question? When the sample size is less than 100, you can use what is called as hierarchical cluster analysis. The first step in the analysis would be to group the different districts based on the percentage of disabled people. Let's now proceed to SPSS. As you can see here, this is my SPSS software, and I have already loaded the data set. The first variable, as you're familiar, is district. I've got total population, seeing disability, hearing disability, so on and so forth. We are going to carry out what is called as hierarchical cluster analysis. How do you begin the first step? To carry out hierarchical cluster analysis, the first thing that you need to do is go to the Analyze menu bar. Here, there are different options. We can move to what is called as Classify. Under the Classify section, we have 7 different options. We have to choose the third option from the top, which is called as Hierarchical Cluster Analysis. Let me select this particular option. As you can see here, under the variable section, I am taking the total population and the 8 different types of disability like seeing, hearing, speech, movement disability, so on and so forth. When it comes to label cases by, I have chosen district, which is the first variable. The clustering can be performed either at a row level or at a column level. Since I'm interested in grouping the different districts, I would like to choose cases here. Though SPSS would display a lot of statistics, I'm not interested in looking at the statistics as far as this analysis is concerned. I'm only interested in looking at the plots. In the top right-hand side corner, you see what is called as the plot. This tab is very, very useful. Let me go ahead and select this particular button. The moment I click on plots, you can see the different options for method. Right at the top, you can see what is called as dendrogram. Dendrogram is a graphical display which gives a summary of the segments that are formed. I like to check the dendrogram so that I can put each of the districts of Karnataka in 3 groups. Once we have done this, let's go ahead and click on continue. The next option here is what is called as method. Let's go ahead and select the clustering method. As soon as you click on the clustering method, the very first option is cluster method. When you click on the drop-down menu here, there are different options. The first one is between groups linkage. We can also choose within groups linkage. The third option is nearest neighbor. The next option is furthest neighbor. Sometimes people also choose centroid clustering. In this video, I will be demonstrating the use of Watt's method of clustering. Almost every cluster measure goes by distance measure. One of the popular ways in which you can check the distance would be through the Euclid's distance method. So I will be using the Euclid's distance method here. There are other interesting methods which we can use for computing the distances. Let me click on the drop-down menu. Here you can see the default option is Euclidean distance. We can also use squared Euclidean distance, cosine measure, Pearson correlation, Chebyshev's distance measure, block, Minkowski measure. Customized options are also present. Let's go with squared Euclidean distance. Standardization of the variables is a good practice when you want to cluster. Let's go ahead and click on continue. If you want to save the group membership, you can click on what is called as the save button. Here, the default option is none. If you choose to select a particular number of clusters, you can click on single solution and specify the number of clusters here. It could be 3 or 4. As a general thumb rule, you can use 5 plus or minus 2. I repeat, 5 plus or minus 2. What does this 5 plus or minus 2 rule say? It says that the optimal cluster will be anywhere between 3 and 7. That is 5 minus 2 is 3 and 5 plus 2 is 7. So you can specify the optimal number of clusters anywhere between 3 and 7. Above 7 will be difficult to handle. Below 3 would be very simplistic. Let me click on, my apologies. Let me click on cancel as far as this option is concerned and go ahead and hit the OK button. In the left-hand side, you can see different options under the output. Let me select the dendrogram. I'm going to double click on the dendrogram using word linkage. As you can see here, in the vertical axis, we have different districts like Ramnagara, Dharwad, Chikmagalur, Chamrajnagar, Yadgir, Bangalore Rural, Gadag, so on and so forth. And in the horizontal axis, we have the rescaled distance cluster combined. As you can clearly see here, the district of Ramnagar, Dharwad, Chikmagalur, Chamrajnagar, and Yadgir have been put in one group. Why? Because the distances are very low. Similarly, Bangalore Rural, Gadag, Kodagu have been clubbed and put in one group. In the next level, you can see there is a process of combining of these two clusters, which further gets combined into the next cluster. As you can see here, the district of Udupi, Chikballapura, Bangalore, Uttara Kannada, Kolar, and Shimoga have been put in the next group. Overall, you can see that there are two groups. The first group would start from Ramnagar all the way up to Shimoga. The second set of districts would be from Mysore all the way up to Bagalkot. So what does this dendrogram tell us? At a very high level, we can break down the different districts into three. Why three? Ideally, two would be a good number. However, I am making allowance for a additional group. Let me now go ahead and close the hierarchical cluster analysis output. Let's come back to the original data set. Let me scroll to the extreme right side. Here, you can see the different clusters that we have obtained. As you can clearly see here, the first cluster is, the first record is cluster 1. Which all districts belong to cluster 1? The district of Mysore and Gulbarga, followed by Tumkur, belong to cluster 1. Then when it comes to cluster number 2, you can see there are different districts like Kodagu, Bangalore, Udupi, Bangalore Rural, and Chikmagalur, which belong to cluster number 2. When it comes to cluster number 3, you have the district of Haveri, Chitradurga, Bidar, and Hassan, which belong to cluster number 3. When you perform any cluster analysis, there are two important questions to ask. The first is, how many clusters should you make? Is it 2? Is it 3? There are two ways in which you can answer this question. The first is through dendrogram, which we have seen just now. The second is through a thumb rule. I've already shared the thumb rule. 5 plus or minus 2 is a good thumb rule criteria that you can use to decide on the optimal number of clusters. In this study, I have grouped the different districts of Karnataka into 3 different buckets. The second question that we would like to ask is, what is the profile of the cluster? There are multiple ways in which you can answer this question. To understand the profile, either you can use a simple method like custom table, or you can use an advanced algorithm like decision tree or two-step cluster analysis. So there are 3 options in which to understand the profile of the cluster. First is custom tables, second would be decision tree, and the third one would be two-step cluster analysis. I would be using the first method, which is quite simple to understand, that is custom table. To perform the custom table, you can go to the Analyze menu bar, choose the 4th option from the top, which is called as Tables. Under the Table section, you have 3 different options. Let me draw your attention to what is called as Custom Tables. Let me go ahead and select this option. This opens up the Custom Tables dialog box. You can see all the variables that we have is present in the left-hand side. And to the right-hand side, SPSS expects me to drag and drop the variables that I need along the row and along the column. You can see cluster group is the variable that I'm interested in, which will give me the breakdown of the clusters. Remember, this is the output of the hierarchical cluster analysis. You have high, low, and moderate. When it comes to columns, I will be selecting all the variables that are present. I've taken variables from total population all the way up to no disability. Let's try and understand the profile of high, low, and moderate. Let me go ahead and hit the OK button here. This is the output of custom tables. As you can clearly see here, the first row represents high, second represents low, and the third represents moderate. Along the columns, I have taken the raw data or the original variables in the disability dataset. Clearly, the first row has high numbers, which means those districts which belong to the high segment have a high population. Have a look at their population. It's approximately 1 crore 88 lakh 348,000. My apologies, this is wrong. It is 18 crore 80 lakh 348,000. So their population is on the higher side. When you look at other information like seeing disability, it is 5,000. Please compare this with the neighboring numbers 1,972 and 3,918. So clearly, the seeing disability, the number of people who suffer from seeing disability is on the higher side when it comes to the first row. The same trend follows for the different types of disability. So may it be hearing disability, speech disability, movement disability, mental retardation, mental illness, other disability, multiple disabilities, the first row has the biggest set of numbers. So what is the conclusion? So those districts which belong to the first row represent high proportion of disabled people. Let's look at the second row. Here, the numbers are a lot lower. The total population here would be approximately 8,94,000. Have a look at seeing disability, hearing disability, speech disability. This is quite low as compared to their neighbors. So those districts which belong to the second group have a very low number of disabled people. The last is moderate. Here, the population is higher than the second row. However, when you look at the absolute numbers, they are less than the first group. Hence, we can call them as moderate. What we have done is to group the districts into high, low, moderate. If you are a bureaucrat, you definitely look at those districts which belong to high, simply because you can identify a higher percentage of disabled people. Now the question is there a different method using which we can identify the profile of the three segments that we have made? Here is where I'd like to show you the second method that you could go ahead and use, which will help us identify the profile of each of these groups. What is this method? This method is called as decision tree. Let me go to the Analyze menu bar. I will be selecting the Classify option. The fifth option from the top is the Tree option. Let me go ahead and select the Tree option. This will open up a new dialog box, which is called as Decision Tree. Decision tree is a supervised machine learning technique. As you can see here, the dependent variable is the cluster group. I'm interested in identifying the profile of each of these districts. The rest of the variables I'm taking under the independent variables section. Let me draw your attention to the growing method. I'm using a method called as cart. However, you're free to experiment with three other algorithms, namely CHAID, which stands for chi-square automatic interaction detection. You have another flavor of CHAID, which is called as exhaustive CHAID. And the last of the options that you have is QUEST, which stands for quick unbiased estimated statistical tree. Let me go with the option of CART, which gives binary splits. Typically, a CART algorithm uses what is called as a Gini's measure, which represents the level of impurity, which is a measure of disorderliness. I'll now go to the output option. Make sure that I've selected the variable importance to the model. You can go to plots and select the option independent variable importance to model. If you are interested in generating rules for high, medium, low, you can select the option generate classification rules. I'm not interested in generating rules, so let me click on continue. Validation. You can perform two different types of validation, either cross validation, or you can do what is called as train test split. The default option is 50% for training and 50% for test. I like to ignore both these options of cross validation and choose none. I can go ahead and look at some of the other options. You have criteria. Please have a look at the parent node. I've reduced the default minimum number of cases option under the parent node. Typically, the number is 100 for the parent node. The number that is the minimum number of cases for the child node is 50. Since I have a very small sample size of barely 30 records, it does not make any sense for me to use high numbers, and therefore I've reduced the parent node to 10 and the child node to 5. Let me click on continue. Now I'll hit the OK button. You can see here, this is the output of the decision tree. I like to show you the independent variable importance chart. Very interestingly, the most important variable. Please have a look at the different variables. This is the vertical axis. The three most important variables is seeing disability, speech disability, and other disability. When it comes to mental retardation, multiple disabilities and mental illness, they are not as important as the first three variables. This is a very, very useful chart. At the top, what you're seeing is normalized importance. At the bottom, what you're seeing is the importance based on the percentage. If you want the numbers for the graph here, you can have a look at independent variable importance table. There are three columns: independent variable, its importance, as well as the normalized importance of each and every independent variable is shown. The overall classification accuracy of the model is shown. This is what is called as the confusion matrix. Along the row, you have high, low, moderate. The predicted class is shown along the column. The overall percentage is 86%. When it comes to percentage of accuracy for the high category, it is 100%. For low, it is 100%. When it comes to moderate, the percentage of accuracy is 66%. The golden rule of interpreting the confusion matrix is to look at the diagonal elements. The diagonal elements always represent the correct classification. The off-diagonal elements represent misclassification. Let's now proceed to look at the profile of each of the clusters. This is the tree diagram which I am looking to edit. This is the dependent variable. This shows me the distribution of each of the categories of segment. The high segment roughly has 3 districts. The low segment has 14 districts, and the moderate segment has 12 districts. The respective percentage would be 10, 48, and 41. Let me scroll down. The most important variable here to classify a district as belonging to high, low, or moderate would be speech disability. If you take a look at the left side, when the speech disability is less than 1,574, the majority class is predicting for low. Majority of the districts belong to low disability segment. Take a look at the neighboring segment. What happens when the number of persons exceed 1,574? The speech disability is exceeding 1,574. The majority class here is moderate. The second important variable here is seeing disability. How do we interpret this? When the speech disability is greater than 1,574 and the seeing disability is exceeding 4,779, it predicts for high disability score. When the seeing disability is less than 4,779, the majority class is moderate. So this is how you can understand the profile of high, low, and moderate segment. So we have seen custom tables. Now we have seen what is called as decision tree. The last thing that I'd like to show you is an alternative to decision tree, which helps us identify the profile of each of the segments. To identify the profile of each of the segments, you can use what is called as two-step cluster analysis. Let me go to Analyze, Classify. Here you have the first option, which is two-step cluster analysis. Once I select this particular option, you can see SPSS expects me to specify the categorical variables and the continuous variables. I've taken district as the categorical variable, and under the continuous variables, I'm taking the different types of disability. Let me go ahead and hit the OK button. This is the output of two-step cluster analysis. You can see here, SPSS has taken 9 inputs. It has made 3 groups. The cluster quality can be determined through a measure which is called as silhouette measure. There are 3 different regions. The pink region, which indicates poor cluster quality. Then you have the fair region. Lastly, you have the green region, which represents the good category. When you look at the bar here, it extends to the fair region, which means that in this data, we have been able to make a fair quality of segmentation. Let me double click on this. This opens up what is called as model viewer. You can see a pie chart here, which gives me the distribution of the members in the first group, second, and third group. In the first group, we have 37% of the districts. In the second, we have 27%. And in the third group, we have 35%. We also have the size of the smallest cluster, which is 8, size of the largest cluster, which is 11, and the ratio of the sizes is 1.38. I'd like to look at which are the important predictors. So let me click on the drop-down menu and select predictor importance. So in this technique, the most important variable is seeing disability. The second most important variable for me to form the groups would be to look at speech disability. The third variable is mental retardation. There are other variables like hearing disability, other disability, and district, which is not so important. Let's now look at the drop-down menu and select clusters. Along the column, you have 1, 3, and 2. 1 represents cluster number 1 and 3 represents cluster number 3. You have the size of each of the clusters, and this is the profile. Have a look at cluster number 1. When it comes to seeing disability, you see a big number. The average is 4,771. When you look at seeing disability for the group number 3, the average is almost half of it. So you have lesser number of people who suffer from seeing disability in cluster number 2. My apologies, 3. When you compare speech disability, the first group has a bigger number as compared to its neighbors. Let's look at mental retardation. It is 1,375, which is quite high. Here you have 1,127, so on and so forth. If you want an easy graphical way to compare cluster number 1 and cluster number 3, we can select both of these. In the right-hand side, what SPSS does is it gives me a cluster comparison graph. The legend here is as follows. The blue represents cluster 1 and the red color box represents cluster number 3. You can see a box plot here which represents cluster number 3, and here you have a box plot which represents cluster number 1. When you look at the blue colored box plot, it is consistently on the higher side as compared to the red one, indicating that those districts which belong to cluster number 1 have a high number of persons who are disabled. You can expect to see higher number of people who suffer from seeing disability, speech disability, mental retardation, mental illness as compared to group number 3. Let's add one more level of complexity and include cluster number 2. Here again, you clearly see the light blue color, which is cluster number 1, is on the higher side as compared to its counterparts, indicating that group 1 is the group which we need to focus on, because here we are seeing a high number of persons who are disabled. The second thing that I'd like to point out is group number 3. Group number 3, that is the red cluster, the red box plot, is between group number 2 and group number 1, indicating that cluster number 3 represents moderate, and when it comes to the dark blue color, it is on the lower side, indicating that those districts which belong to cluster number 2 are on the lower side. In this video, we have seen how to get a dendrogram. We have seen how to perform HCA or hierarchical cluster analysis. Then we went on to identify the cluster profile using custom table. We performed the decision tree as well as two-step cluster analysis. I thank you very much for watching this particular video. I request you to subscribe to my channel, also like and share my videos. Thank you very much once again. Have a great day ahead.